Hi, Sagambuta Emmanuel here once again. Now, this video is meant for actually those who are at colleges, those who are at universities. Please, it is also still coming from genetics. It's, but now, this time around, I would want to advance it a bit. So this content is not meant for those who are at secondary. Please, this one is not for you. This one is meant specifically for those who are struggling to understand dihybrid crosses at colleges as well as at universities. So now I decided to do this video because a lot of people tagged me. They inboxed me saying that no, you simply focus on grade 12, the secondary level. Why can't you just further it? Why can't you advance it a bit? So I decided also to consider that so that no one is left behind. So we're going to look at dihybrid crosses. Now, let me just give you a synopsis to this. And when we look at dihybrid crosses, remember the crosses that we've been dealing with, we were just focusing on a single characteristic. So we're looking at the monohybrid cross. Now, this time around, we are focusing on two characteristics or traits. So because of that, we normally advise that when you're dealing with dihybrid crosses, the hybrid problems, we use the Punnett square. The Punnett square can actually help us, clear all the problems that we have on dihybrid crosses. So remember that dihybrid crosses, we are dealing with two characteristics. Now, I want us to examine this question so that we see how we are going to approach it and how we're going to answer it. Okay, so the question is saying, an aquatic arthropod called a cyclops has antennae that are either smooth or barbed. The allele for barbs is capital B, which is dominant over smooth. So this is one characteristic that you're talking about here. Okay. In the same organism, non-resistant to pesticides N is dominant over resistance to pesticides N. This is also another characteristic. So we have how many? Two characteristics that you're looking at here. So we're saying a cyclops that is resistant to pesticides and has smooth antenna is crossed with one that is heterozygous for both traits. First question, what are the possible genotypes of the offspring? Second question, what percentage of the offspring will be barbed and resistant to pesticides? Now, how I normally approach the hybrid crosses, I approach the hybrid crosses in this way. So the first is to identify the alleles that you're given in the question. So what we have here is that we have this cyclops that has antenna, and these antenna can either be smooth or barbed. So we are told that the allele for barbs, the allele is capital B, which is dominant over the smooth antenna. So smooth antenna is actually recessive. So it's a small b like this. And then we are also told that the organism non-resistance to pesticide. So let's write non-resistance to pesticides is N, which is dominant over resistance to pesticide. So resistance in this case happens to be recessive. So small n like this. Now we have this characteristic. We also have this characteristic. So there are how many? There are two characteristics that we are looking at here. Now the first question is saying, a cyclops, the statement is saying, a cyclops that is resistant to pesticides. So the only way the recessive allele for resistance can be expressed is when it is like this. This is the only way it can be expressed. Now, they're saying is resistant to pesticide and has smooth antenna. Now, the smooth antenna is a small b. And the only way this recessive allele can be expressed is when it appears like this. So meaning we have resistance and smooth antenna. Now, we are also told that this is crossed with one that is heterozygous for both traits. Now, it's very important here to understand these terms because in genetics, we need first to understand the genetic terms that are used. Because once you understand those, then it'll help you to approach these questions correctly. Now, heterozygous, we are talking about a situation where we have now non-resistance, and this non-resistance is heterozygous. This is heterozygous. Why? Because we have capital N, which is dominant over small n. So meaning that this is heterozygous. So the genotype here is heterozygous. Now, they're saying it's for both traits, meaning that we're going to have also capital B and small b like this. So this is what we mean here when we say is heterozygous. So meaning that here, what we have here is that the genotypes are not homozygous. They're not the same. So they are heterozygous. So once you've done this, you now do what you call a single monohybrid cross. So what you simply do is you just do like what you've been doing. This cross will be crossed with that. You have NB, this with this, NB, this with this, NB, this with this, NB. And then you also come to this one. You do the same. This with this, you have any B. Now, capital letters. This with this is going to give us any B, capital and small b. This and this is going to give us any capital B. This and this is going to give us any B like this. Please remember to maintain the consistency. So if N here, N here, N here, N here, it should be N throughout. If you start with B, the B also should appear just like this. So maintain the consistency. Then once you've done this now, you now come up with what you call the Punnett square. So how does this happen? I know it's challenging. Others find it difficult for them to come up with the Punnett square, but I'll show you a simple way of doing it. So what you're going to do here is this. You're going to draw a table like this, like this, like this, like this. And then once you've drawn this table, you just divide it into two, like this. You also divide here into two, like this. And then you also divide this into two, this into two, this into two, this into that. Then you got it. So this into two, this also into two. And then finally, this into two, and this also into two. So it has to give you 16 boxes when you count. So now what is going to happen is that this is going to be here and B. This allele is going to be here. This also is going to be here. This is going to be here. These will be on top here. So N capital B, okay, small b and B like this. Then after you've done this, what follows now is simple because you simply multiply. So this and this is going to be capital N, small n. The reason we're starting with capital N because N is dominant over, capital N is dominant over small n. So it's better we do it like that. That's the correct way of doing it. And then B and B, so the one which is dominant is written first and then followed by the recessive. So this and this, you follow the same order. It's gonna be this, this, this and that. You're now filling the table, the rest of the table, the rest of the boxes in the similar manner. So this and this gives you this, this, and this. It gives you this, 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 this and this gives you N, capital B, B. This and that, capital N, small b, B. This and this, small n, B, capital B, small b. This and that, small n, B, B. This and this, capital N, small n, capital B, like this, small b. This and that, this and this is going to give you this, and then here, small b, B, small b, B. This and that, small n, and then capital B, small b. This and that is going to give you small n, B, B, small, small. This and that, capital N, small n, then capital B, small b. This and that, capital N, small b, small b. This and this, N, N, capital B, small b. This and that, finally, it gives you this, a small n, and then small b, small b. So this is the table that you have made. So this is the Punnett square. Now, once you've made this table now, it will help you to answer the questions that follow. So the question is saying, let me just do this so to be able to say properly. Okay, so the questions are saying, what are the possible genotypes of the offspring? So these are the possible genotypes of the offspring. So there's no need for you to repeat this. So you simply just indicate that this is it, that. And then what percent of the offspring will be barbed and resistant to pesticides. So now, here we're looking at it. Let me just do this. We're saying what percent will be barbed and the resistant. Okay. Now, remember, barbed is the dominant. So capital B. So this is going to be like this, barbed, and then resistant. It's going to be resistant. So the only way it can be resistant is when it's expressed as small n like this. So meaning we need to look for this type of genotype in the table. Let's see if we can find it. Okay, so by the way, since we are maintaining the consistency, it's better this comes first and then this one comes on the other side. So you're going to have n, and then capital B, small b like this. Okay, so let's check in the table. Do you have this? Here, it's not here. If you can see in the first row, it's not there. Here also, it's not there. Here, we have this. Yes, 1, 2, 3, 4. Okay, where else do you have this? This is something else. So it's only here where you have this. So there are how many? There are 4. So now the question is saying what percent of the offspring will be barbed and resistant to pesticides. So we're going to say, so how many? 1, 2, 3, 4. So we're going to say 1/4. So this is going to be expressed in terms of percentage. So times 100%. And this is going to give us a simple mathematics now. This into this 1, this into this. This is going to be 25. So 1 times 25 is going to give us 25%. So what you're saying is that the percentage of offspring that will be barbed and resistant to pesticides is going to be 25%. It's going to be 25% like this. So this is how you solve dihybrid crosses. And please stay tuned because I'm going to, throw a lot of questions of this nature so that you'll be able to get it right, so that you'll be able to understand, just in case it comes on a test or in the exam, you'll be able to write properly. Thank you very much. Please do well to share, subscribe on our YouTube channel also. You'll find this amazing content. Please follow our YouTube channel. Please hit the subscription button on the YouTube so that every time you'll be able to get a notification, and then you'll be able to watch this kind of amazing content. Please, I want to make this clear. Don't just watch, please. Watch, share, and also like, because once you share, you are also caring for someone who is also in need of the same knowledge. Thank you very much. Thank you very much for your support. God bless you. Thank you.